Hello everyone, I'm Pratima Samineni representing Group 18. So today we are going to explain about the three research papers based upon the artificial intelligence. So to start, I'm going to explain about the research paper based on the history of artificial intelligence. So what actually the artificial intelligence is? So it is an intelligence exhibited by machines, and also it is an ability of a computer or a robot controlled by a computer to do some tasks that are not usually done by the humans because they require human intelligence and discriminant. So the AI wasn't formally founded until the year 1956 by John McCarthy. He's one of the scientists. According to him, the science and engineering of making intelligent machines, especially intelligent computers. AI is sometimes called as a machine learning. According to the scientist McCarthy, uh, in the year 1956, he organizes a conference where the interested scientists join the conference, and it is extended to 8 to 6 weeks. In the end of the name, artificial intelligence was coined. While exploring the power of computer systems, the curiosity of humans led him to wonder, can a machine think and behave as humans do? Then the development of AI started with the intention of creating similar intelligence in machines than we find and regard high in humans. There was some history, like the year 1965, the scientist Robinson's complete algorithm for logical reasoning, and after the years continue and still the artificial intelligence is in use. So there are three types of artificial intelligence. One is an artificial narrow intelligence, abbreviated, and artificial general intelligence and artificial super intelligence. So while coming to what actually they are is, artificial general intelligence refers to a computer that is as smart as the human across the board. While coming to the artificial super intelligence, an intellect that is much smarter than the best human brains in every practical field. So coming to the next slide, Turing test. What actually the Turing test is, it is developed by one of the scientists, Alan Turing, in 1950, is a test of machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Uh, this test requires three terminals, each of which is physically separated from the other two. One terminal is operated by a computer, while the other two are operated by the humans. During this Turing test, one of the human functions as the questioner, while the second human and the computer function as respondents. The questionnaire interrogates the respondents with a specific subject area using a specified format and the context. After a preset length of time or number of questions, the questioner is then asked to decide which respondent was human and which was a computer. Basically, the Turing introduced this test in the year 1950 by writing a paper called as a Computing Machinery and the Intelligence in the university called Manchester. In this paper, he proposed a twist that is called as a limitation game. What actually the limitation game is, uh, it involves no use of artificial intelligence, but rather than three human participants in three separate rooms. Like I said earlier, there were three terminals are used. So he considered it as a separate rooms. So three terminals is considered as a three rooms. So there are some variations in the Turing test, reverse Turing test, and the minimum intelligent signal test. So the reverse Turing test is a where a human tries to convince a computer that is not a computer. Well, coming to the minimum intelligent signal test, where only true or false or yes or no questions were given. So this is all about the Turing test he invented. And there are some alternatives and limitations to the Turing test. So the Marcus test and the Lovelace test 2.0 and Wingott schema challenge are the alternatives for these Turing tests. But coming to the limitations, these are mainly focused on finding clever ways to fool judges than using the overwhelming computing power. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. On the other side, we're coming to the history of artificial intelligence applied to the chess. As we all know, chess is a game. So it is an analysis of the use of computers in playing chess, specifically middle game strategies. So how the artificial intelligence take part in this game chess is like the scientist who proposes is the Claude Shannon, who first wrote a paper about developing a chess playing program. And it also describes how a machine or a computer could be made to play a reasonable game of chess. So he proposed two approaches, like a type A program and the type B program. Now, most of the applications are using this type A program rather than type B. So because the type A follows the brute force search algorithms, which looks at every variation to a given depth. Well, coming to the type B, it follows a selective search looking at an important branches only. Like a Shannon process for having the computer decide on which move to make is a minimax procedure. Here, the minimax is one of the algorithm followed by the chess, and it is also based on the evaluation function of a given chess position. Shannon demonstrated to the chess master Edward his named it is one of the homemade electric chess automation. It is built in the year 1949. The machine could handle up to 6 pieces and was designed to test various programming methods. In the year 1973, the creators of the chess series of programs won the ACM Computer Chess Championship in 1970 to 1972, moved to Type A. That the new program, called as the Chess 4.0, went on to win a number of ACM Computer Chess Championships in the future. It had built into random element and as a result and did not necessarily always make the same move when faced the same position. So as I said earlier, in the chess game, they use the minimax algorithm. So what actually the minimax algorithm is, so it takes advantage of the fact that chess is a zero-sum game. The maximizing our chances of winning is the same as the minimizing the opponent chances of winning. So here is the formula that this algorithm uses. The minimax is equals to maximizing gain plus minimizing loss. So this is one of the evaluate function which follows the brute force approach. And this is a basic method used by the chess program. And this minimax algorithm is also called as a search algorithm, which involves a search tree or a way of representing a board and all the possible moves to be made from that position on the board. Each turn can be seen as a player making a move to maximize the evaluation function while the other tries to minimize it. In terms of this process, in terms of a search tree, this means starting a given node and choosing the children nodes with the best scores. Minimax is a correct way to do this in this sense that if we were to let it go on indefinitely, then it would play the game perfectly. And this minimax algorithm is not only used by the chess, but also in a variety of other two-player games. Well, coming to the other part, which is an expert systems, what actually the expert system is, it is a computer expert that emulates the decision-making ability of a human expert. It is also known as a knowledge base one. A knowledge base is like organizing collection of facts about the systems domain. The facts for a knowledge base must be acquired from human experts through interviews and observations. For example, a medical diagnosis expert system lets the user diagnose his disease without going to a real doctor, but user has to go to a real doctor for treatment. So this is one of the best examples to represent the expert systems. There are mainly three components of an expert system. One is a knowledge base, inference engine, and the user interface. What the inference engine interprets and evaluates the facts in the knowledge base in order to provide an answer or to reach a goal state. So there are two strategies followed by the inference engine. One is a forward chaining and another one is a backward chaining. And there are also the few technological issues and performance limitations that affect the development of expert systems. And there are software standards and methodologies, knowledge acquisition and handling uncertainty and validations. Here we can see in a picture, like the user interface is interlinked to the rules engine and knowledge base. So a knowledge from an expert, and on the left side there is a user. And the input is provided, and the advice is coming as an output to the user. Well, coming to the next slide, which is an AI winter and its lessons. So this is one of the stage where technology, business, and the media get out of their warm and comfortable bubble, cool down, temper their sci-fi speculations and unreasonable hypes, and come to terms with what artificial intelligence can or cannot really do as a technology. In 1984, a scientist named as Marvin Minsky, he is one of the pioneers of the artificial intelligence industry, and also a survivor for the first AI winter. The decisions were often attributed to a couple of infamous reports. There are two reports in the year 1996 and the 1974. In 1996, the report named as a ALPSC, and in 1974, the report named as the Light Hill. There were two major winter periods. The first period is a 1974 to 1980, and the second period is a 1987 to the 1993. So during the AI winter, many ambiguous names came up during this time, such as machine learning, informatics, knowledge-based system, and pattern recognition. AI winter is a quiet period for artificial intelligence research and development. The label winter is used to describe dormant periods where customer interest in artificial intelligence declines. So this is all about the AI winter of artificial intelligence. Well, coming to the conclusion part, uh, the artificial intelligence is at the center of a new enterprise to build computational models of intelligence. Like, finally, we can say that the artificial intelligence is the intelligence of machines and the branch of a computer science that aims to create it. John M.C. Carthy, who is a scientist who coined the term in 1955, defined it as the science and engineering of making intelligent machines. So this is all about the history of artificial intelligence. Yeah. So the next part of the research paper is continued by my teammate. Thank you.
Hi, this is Gautam Kumar Naluri. Today I am going to explain about why Python is most commonly used language in machine learning and the main developments in machine learning and artificial intelligence. Here, why we use Python in machine learning. As Python is most commonly used language for data analysis, and due to its syntax structure makes developers most commonly used language. And also Python have rich frameworks, and Python's accessibility allows developers to write basic code that is straightforward to implement. There are some researchers on Python's strong side and find out why we have to opt for Python when bringing your AI and machine learning projects to life. Those are a low entry barrier capability for Python, and also flexibility in coding, and it is a platform independence. It has a readability, good visualization options, and it has rich community support. Coming to its libraries, yep. These are the few frameworks and libraries available in Python. So pandas is one of the most common used library because it is mainly focused on data manipulations and analysis. It contains some manipulation tools that is used for data cleaning and analysis. The NumPy and SciPy are used for numerical computations, and for analytic libraries like we have scikit-learn, and for data visualization libraries we have matplotlib. It adopts significant parts in NumPy's like array-based computing, and also it has a shell environment for executing the Python code, where we have syntax highlighting, code completions, and also more interactive features for the user. There are different frameworks available in Python, which are divided into three parts: full stack frameworks, micro frameworks, and also asynchronous frameworks. Django, Web2.py, Pyramids are comes under a full stack, whereas Flask, Falcon, Hug comes under micro frameworks. And there are few frameworks like Tornado, Sonic, which are asynchronous frameworks. And coming to next slide, classical machine learning. Classical machine learning is nothing but we are supplying input data and along with the output also, and we are expecting the algorithms to map this input data with the output variables. So classical machine learnings are divided into two parts. One is supervised and another one is unsupervised. Supervised machine learning is nothing but we are supplying the input variables and we are giving the output to the data, and we are expecting it to be matched that exact input variables with the output variables. For this, again, we have different algorithms which are divided into regression classifications. For regression algorithms, we have linear, non-linear, and Bayesian linear regression algorithms. And for classification, we have SVM, logistic regression, decision tree, and random forest. Mostly these supervised learning processes are used in fraud detections and spam filtering. Coming to unsupervised learnings, these unsupervised learnings are used in unlabeled data handlings. These are mostly used in for handling big data, and there are few algorithms which support unsupervised learnings like K-means clustering, KNN, hierarchical clustering, and neural networks. Yep. Next slide, please. Coming to automated machine learning. Automated machine learning allows data scientists to focus more on other challenges because it provides more inputs to the user. H2O AutoML and TPOT are some things like it provides Skylette-Lane APIs. These APIs are used for mostly handling the big data. There are some tools that are handling these automatic machine learning such strategies that are initial data preparation, feature engineering, hyperparameters optimization, model evaluation, and neural architecture structure. In data preparation step, we use it to get the data and map the fields to the data, which is used for feature engineering. There are these H2O AutoML is one thing which is used for this automation purpose. They can directly map the data type to the exact data. And coming to hyperparameter optimization, there are a few models which are created from automated ML by using different scenarios. Among the designed models, we are going to take a optimized model for the as a output for better performance. Those optimized model is known as hyperparameter optimization. For doing this, we need to follow several methods like manual search, grid search, randomized search. And coming to neural architecture search, it works on the principle like better the design, better the performance. The NAS helps minimize the time and cost involved in design expectations. To do this process, we have four categories. One is structure, one is cell-based and hierarchical and morphism-based structure. These morphism-based structure used to transfer knowledge from existing well-performing network to a new network. Yep. Coming to next slide. Here we are going to discuss about GPU. GPU helps to execute different processes simultaneously. The usage of GPU in machine learning will speed up the data transfer process, and each GPU consists of minimum 700 cores to maximum 4,000 cores. Here, due to the availability of these many resources, we can easily handle big data without any interruption. GPU is designed to quickly render high-resolution images and videos concurrently. It can speed up the machine learning process. There are few features available for GPU. Those are high standard, high speed memory bandwidth, shared memory, extreme parallelism, and reads and writes into a global memory. Yeah, coming to next slide. Here we are going to discuss about deep learning. Deep learning is the subset of machine learning. Here we can see the difference of both three: artificial intelligence, machine learning, and deep learning. Here in artificial intelligence, the humans are expertly need to write the programs to instruct the systems what to do. Whereas coming to machine learning, it can learn what it has to do. Like the humans need to write the programming for that missions. For coming to deep learning, in this deep learning, users are using artificial neural networks that replicates how brain works. So for achieving these features, we need to implement some features like static data flow graphs, dynamic graph libraries with eager execution, JIT and computational efficiency, and deep learning APIs. So the predictive analysis depends on data processing and future engineering for constructing the dataset that will be used to train the models. While these classical machine learning are often problematic when working with the high dimensional datasets, the algorithms are suboptimal for extracting knowledge from raw data such as text and images. So while doing these processing like image processing and data from the huge data set, these deep learning mechanism will be useful in that scenarios. In conclusion, I can say Python is the best programming language by its high and rich support in libraries and frameworks for analyzing these high data set. And coming to machine learning and deep learning processes, we can expect more technologies and more information extracting from these technologies in the future, coming future. Yeah, thank you. And my friend will continue on the slides.
Hello all, my name is Murali Krishna Bhumisetti. So today I am going to talk about the research paper benchmarking contemporary deep learning hardware and frameworks, a survey of qualitative metrics. So here we are going to cover three topics. One is benchmarking principles, machine learning devices, and deep learning software frameworks. And along with that, we are also going to take a look on technologies involving benchmarking from the point of view of a 6-metric approach to frameworks and 11-metric approach to hardware platforms. So coming to the introduction, there are 7 characteristics for benchmarks: relevance, repetitiveness, equity, repeatability, cost effectiveness, scalability, and transparency. So deep learning technologies are still in the early stages of development. Adding more photos to their algorithms improves their learning. The higher the visual quality, the better the learning. The definition of benchmarking is to analyze or check against an established standard. Comparing deep learning neural networks through benchmarking is very important as they extend their computing performance and capability based on flexibility, distributed architectures, creative algorithms, and large volume datasets. In this paper, we are going to talk about 11 qualitative benchmarking metrics for hardware devices and 6 metrics for software frameworks in deep learning. Uh, the paper also provides qualitative benchmark results for major deep learning devices and compares 8 deep learning frameworks. So deep learning hardware. AI algorithms performance often depends on computational power. The computational power depends on hardware design. The hardware design is to improve computational power, often depends on GPUs, FPGAs, ASICs. They have strength for parallel computing and high-speed internal memory. So they have potential to improve machine learning algorithm performance to a greater extent. So coming one by one, so GPU devices, GPUs are specified unitary process that are dedicated to speed up real-time 3D graphics. GPUs contain an internal cache, high-speed bandwidth, and quick parallel performance. The GPU cache give boost to matrix multiplication routines because these routines do not need to access global memory. GPUs are universal hardware devices for deep learning. FPGA devices. FPGAs have dynamical hardware configurations. FPGA offer better performance per watt than GPUs. While comparing gigaflops per watt, FPGA devices often have a 3 to 4x speed compared to the GPUs. Now coming to the ASIC, ASIC devices have high throughput and low energy consumption because ASICs are fabricated chips designed for special applications instead of generic tasks. Enhance hardware performance. The memory hierarchy on these hardware devices is usually separated into two layers. One is off-chip memory and second one is on-chip memory. After copying data from global memory, deep learning algorithms can use high-speed shared memory to step up computing performance. Specific program libraries are also improve computational performance. Along with that, multiple cores and improved IO bandwidth also improve computational performance. Co-design of deep learning algorithms and hardware devices are other approaches. There are two solutions. One is decreasing precision and reduce the number of operations and model size. And next one is qualitative benchmarking metrics on machine learning hardware. GPUs, FPGAs, and ASICs can be used in different domains beside deep learning, including cloud servers and edge devices. There are 11 qualitative benchmarking metrics we distinguish on machine learning devices. They are computing performance, latency, energy efficiency, compatibility, research costs, research risk, upgradability, scalability, cheap price, Ubicom, time to market. So coming to mainstream deep learning frameworks, there are three types of frameworks: mature frameworks, developing frameworks, inactive frameworks. Along with that, we are going to discuss about the qualitative benchmarking metrics for deep learning frameworks. Open source deep learning frameworks allow engineers and scientists to define activation functions, develop special algorithms, train big data, and deploy neural networks on different platforms. T18 frameworks are three sets, including mature frameworks, developing frameworks, and inactive frameworks. So mature frameworks, these are the mature frameworks: Cafe and Facebook Cafe 2, Chainer framework, DyNet framework, MXNet, Microsoft CNTX, Google TensorFlow, Keras, Neon and PaidML, PyTorch framework, Theano framework. Developing frameworks are Apache Signa, BigTL, CUDNN, Paddle. Inactive frameworks are Torch, Brain, Torch Brain. So coming to qualitative benchmarking metrics for deep learning framework, they are license types, interface codes, compatible hardware reliability, tested deep learning network, tested datasets. So next we are going to discuss a machine learning benchmark organization. MLPerf is a benchmarking group for machine learning. Members are affiliated with a cutting-edge chip hardware and top-tier research institutions. Benchmarking measures, datasets, deep learning algorithms, and deep learning frameworks are all part of benchmarking process. For MLPerf training or interference benchmarks, time is an important measure. So coming to the conclusion, the technology can be used to classify images, recognize speech, and translate languages. Many new chipsets, useful frameworks, models, and enormous datasets are being developed, allowing the deep learning market to grow. While deep learning technology advances, it is critical to comprehend the dimensions and methodologies for assessing its effectiveness. CPUs, GPUs, FPGAs, and ASICs are most common deep learning hardware platforms. Representativeness, relevance, equity, repeatability, and affordability are some of the benchmarking criteria. In compared to many non-AI algorithms that are commonly encountered in reality, AI algorithms benefit from many core systems and high bit memory. Because FPGAs are programmable, they can be set up to run AI algorithms successfully. However, they currently lack the complex software layer needed to be as valuable as they could be. Deep learning benchmarks can help link industry and academia. MLPerf is a new and preeminent deep learning benchmark organization. The organization offers metrics, dataset evaluation, test codes, and result sharing. We compared 16 popular deep learning frameworks through licensed hardware devices and tested deep learning algorithms. So that's all about all our research papers. Thank you all.
Thank you, everyone.